Hello everyone. In this video we will learn the integrals of trigonometric functions. Now we know that the derivative of the trig functions are here. The antiderivative or the integration is going to be the opposite. So if I want to find the derivative of sine x is cosine x, if I go backward, the derivative of the integration of cosine will be sine, don't forget plus constant. If the derivative of cosine is negative sine, then the derivative of sine, missing the negative, comes here, negative cosine. The derivative of the integration of secant square will be the tangent plus sine constant. The integration of secant tangent will be secant plus constant. Now, the integration of a cosecant cotangent will be negative cosecant x. Finally, the derivative of cosecant squared will be negative cotangent plus constant. Let's try to use these formulas to solve these questions. Now here I need to find the antiderivative of this function. First of all, I need to expand to rid out of these parentheses. That's going to be sine x cotangent x dx plus the integration of sine x cosecant x dx. Now I'm going to make this cosine over sine. I'm going to make this 1 over sine. So that's going to be sine x multiplied by cosine x over sine x dx, and then plus the integration of sine x multiplied by 1 over sine x dx. Now I can simplify by crossing out the signs, and that's going to be cosine x dx plus the integration of 1 dx. Now the integration of cosine is sine x, because the derivative of sine x is cosine x, plus the integration of any constant k will be kx plus constant. Or you can say if this is x to the power of 0, that will be 1 x to the power of 0 plus 1 over 1, which means x. And then don't forget the constant. Okay, now what about this question here? We're going to follow the same steps. I'm going to split. So it will be 2 x to the power of 0 dx plus 5 sine x dx minus pi x to the power of 0 dx. That's going to be 2x plus 5. Now the derivative of cosine x is negative sine x. So now if I go backward, the integration of sine x will be negative cosine x. I'm going to put the negative here. And now plus minus pi x. Don't forget the constant. Let's try this question here. It will be negative 2 cosine t dt. That's going to be equal to negative 2. The derivative of sine is cosine, so that's going to be sine t plus constant. Now what about this one? Negative 3 cosecant squared x dx, which is equal to negative 3 now. Cosecant squared, the derivative cotangent is going to be negative cosecant squared x. Now I want the integration of the cosecant. It will be negative cotangent x plus constant. Just make it simple. 3 cotangent x plus c. Now this question here, it will be a 1/2 cosecant theta cotangent theta d theta. Now, as you know, the derivative of cosecant theta equal to negative cosecant theta cotangent theta. So if I want to find the integration of this, it will be negative cosecant theta, 1/2, then negative cosecant theta plus c. That's going to be negative 1/2 cosecant theta plus c. Now, what about this question here? First of all, we know that negative 1/3 can be moved out, so it's going to be negative 1/3 the integration of cosine 4x dx. Now, we know that the derivative of sine 4x is equal to cosine 4x, but there is the derivative of the inner function. Remember, it should be 4. Now, I do have cosine 4x, I don't have 4. I need to multiply by 4, so I need 4 here. So I'm going to put 4 here. And if you multiply by 4, you need to also divide by 4 at the same time, so you can divide by 4. However, I don't need the division inside, I could move it outside. So how can we write this? I could say it's negative 1/3 integration cosine 4x dx. Whatever I'm adding here as a multiplication, I'm going to divide it here. Now, we know that this part is going to be sine 4x plus constant, right? Now, what about these two? It will be negative 1/12. Let's try this one now. It will be 7 integration sine theta over 3 d theta. Now again, we all know that cosine theta over 3, the integration, the derivative is going to be equal to, the derivative of theta over 3 is 1/3, negative sine theta over 3. That means negative 1/3 sine theta over 3. So what happened? I need 1/3 or negative 1/3. It does not matter. You can say 1/3 and then later on you will say negative 1/3 here. That means I'm going to put 3 here. Now, it will be 21 negative cosine theta over 3 plus constant. That's going to be negative 21 cosine theta over 3 plus constant. Now this one, I'm going to split 1/2 and then this one here. So it's going to be the integration of 1/2 dt plus the 1/2 integration of cosine 4t dt. Now again, we know that the derivative of sine 4t is equal 4 cosine 4t. So I am missing the 4. So what I'm going to do, I'm going to put 4 here and down here, out here. And that's going to be equal to the integration, 1/2 is 1/2 t plus 1/8. The integration of 4 cosine 4t is sine 4t plus constant. Now this question, I'm going to say the integration of 2 tangent squared 4x dx plus pi dx. Now I have a problem. Tangent 4x, there's no function that the derivative of that function is going to be equal 4x. So tangent square 4x. So what we're going to do, we will use one of Pythagorean identities, tangent squared theta plus 1 equals secant squared theta. If I move the 1 to this side, it will be secant squared minus 1. I'm going to come here, substitute, replace tangent squared for x by secant squared minus 1. So it will be 2 secant squared for x. I'm going to use the same angle for x, minus 1 dx plus pi dx. Now you can expand the 2 to secant squared for x plus minus 2 dx plus pi dx. Now again you can expand or split the integration. 2 secant squared for x dx minus 2 dx plus pi dx. Now we all know that the derivative of tangent x is going to be secant squared x. However, I'm not looking for tangent square. I'm looking for tangent x. I'm looking for tangent 4x. 4 secant squared 4x. So I need 4. So what I'm going to do, I'm going to add 4 here and divide by 4 here. So that's going to be 1/2 tangent 4x, and that's going to be minus 2x plus pi x plus c. Let's look at this question now. The integration of cotangent square for x. Again, there's no function. The derivative of that function is equal to cotangent square. So we are going to use another identity here, which is going to be cotangent squared x plus 1 equal cosecant squared x. Now if I move the 1, I'm going to replace cotangent squared for x by cosecant squared for x minus 1 and dx. Now I can split cosecant squared for x dx minus 1 dx. Now you might know that the derivative of cotangent x is equal to negative cosecant squared x. Now I don't have x, I have 4x. So cotangent 4x, the derivative is equal to negative 4 cosecant squared 4x. So I need 4 here and 1/4 out. Now the integration 1/4. The integration of 4 cosecant squared is negative cotangent 4x minus the integration of 1 is x plus constant. So finally negative 1/4 cotangent 4x minus x plus constant. That's everything for today. Please let me know if you have any question, and see you in the next video. Bye bye.